Okay, we're gonna move on because I've gotten very silly. These are the top 10 myths.
Yeah, let's go into the myths. That's gonna be the fun part. Let's just talk about the myths.
These are the myths of video game optimization. Right.
Myth number 1.
Yeah. Okay. Myth number 1: premature optimization is the root of all evil. Well, it sounds like there needs to be a pill for that.
Yeah, seriously.
Seriously, does anyone here suffer from premature optimization? I mean, I don't, but then again, I'm still pretty young. All right. Before accusing, I can't do this. So basically, wow. Can I take that seriously? Okay.
No.
Not anymore.
No.
Not anymore. All right.
So dumb.
You want to get into optimizing as soon as possible.
Yes. As soon as you can.
Yes. Start creating your game roadmap with recommended and required minimum hardware.
Because optimization is a part of your design.
Yes. It is. It is. If you're writing your GDD, one section of your GDD needs to be technical specs.
Yeah.
In that technical specs, you need to have such things as minimum requirements, recommended requirements, etc. And you should probably start putting down what your settings are for low, medium, and high.
Drass, no. Behave.
Wow. I love this chat. But yeah, start putting it down as soon as you're writing your GDD.
Yeah.
You know what engine you're going to create your...
You better know what engine you're using.
Yeah, so start writing that shit down as soon as humanly possible.
Ooh, myth number 2.
Less
oh my god.
code is faster
Less code is faster than more.
What? Who the heck? I don't know.
What the hell?
No. Optimized code is better.
Oh my god.
Code that accomplishes things, more optimal, for lack of a better term. Now that's better. But you can have a whole ton of code, and if your code is calling correctly, if you're calling your variables, if your classes are well organized, if they're all working, if not everything is a public variable, please, then yeah, your code is going to run optimally. You don't have to worry about, having short, tiny little calls, function calls, in order to keep your game optimized, because that's not going to matter. It's not going to matter. It's how well do those different parts of your code work. How optimal are they? And I can't really use another word. My thesaurus is broken. So whenever you're coding, the best thing to do is to work on have it be so that each piece of your code, whether it be a class, a function call, have it be that it accomplishes what it needs to accomplish with no other BS attached to it. Know when to have your variables be private.
Yeah, Drass says they call it refactor for a reason.
Thank you. Yeah, that. Okay. Myth number 3. Game developers don't do multi-core well. What kind of insult is that?
What?
Okay, first off, we don't have to do a lot of that anymore. The game engines do that for us.
Yeah, they do.
The code bases do that for us.
It's all handled for us.
People far more intelligent than you and me have spent a very long time creating optimal ways to run on multi-core CPUs and GPUs.
Yeah.
So that we don't have to. That's not even a factor.
Yeah.
That's not even a factor. So, number 4. Every optimization yields some performance gain. Not true.
That's not true.
Not true.
Oh boy.
And optimization and performance gains are not equal. You are going to see a different level of performance gain when you shift from 16-bit anti-aliasing TXAA to, I think it's TXAA, to 8-bit than you would if you turned off dynamic shadows.
Mm-hmm.
You're going to see a different gain. It depends on what is happening, on what the actual engine is being hit with.
Yeah.
What is your renderer trying to accomplish at any one given moment? Okay. Each one of those little elements are going to hit your renderer and thus your hardware differently. So yeah, it is actually pretty asinine to think that any optimization is going to get you the same amount of performance gain. This is actually kind of a very good list of how not to think as a game dev.
Wrath put out a comment, avoid parallel events and things in the update codes if you can.
Yes. Parallel events, of course, going all the way back to the RPG Maker engine uses it. That's what they call it, parallel processing, parallel events. But the reality is any engine, it's pretty much when you're processing in parallel.
Yeah.
So if you're doing 12 things constantly at exactly the same time, and every time the game engine ticks, it's updating those same 12 things ad nauseum, ad infinitum, it's going to cause a hell of a...
Of course it is.
Yeah, it's going to cause a huge thing. Learn when to update something. Learn when to refresh something. If you have a mini map, that one is probably going to update a lot more than, you know, checking the in-game radar as to whether or not your character is near a quest objective.
Exactly.
Because with an in-game mini map, you are changing constantly what is being displayed within that mini map viewport. However, that mini map viewport's not as big, so it's going to have less of a performance hit.
Yeah.
As if it was bigger. So all that has to be taken into account. The size of the viewport, what is being rendered, what does the player see, and how often is it running? Is it running every 1 tick, 5 ticks, 12 tick? You know?
Yeah.
That kind of stuff. Yeah. Yes, the wait times. Wait times for anything that's running in parallel, please put a wait time.
Yeah, please
Just put a wait time. Even if it's like a microsecond, a millisecond, that can make all the difference in the world. Myth number 5. Reducing instruction processing is our primary goal in CPU optimization. I don't even know.
What?
No, I mean, I know what is being written there, but I don't know why someone would think that.
Oh, wow.
It's not what is being processed. It's not what the instruction is. It is the instruction something that is going to be really hard? Is it going to hit like, does your instruction require a real-time ray trace of water surfaces? That is going to be, even if it's like a single instruction, even if it's just one little thing that's telling the CPU, hey, check for this puddle, that's going to hit a hell of a lot harder than an instruction that causes a tank to roll through a brick wall. You know, that's more instructions that are going to be less intensive than ray tracing that goddamn puddle. Just stuff like that.
Just stuff like that.
I know I'm using a lot of generalization here, guys. It's just simply because, you know, there's so many variables that come into this. A lot of this is like, don't be black and white. Well, Chris has brought something very good. Because similarly, try not to do the same work every update loop.
Yeah.
Right. Many things can wait multiple frames before being rechecked, such as raycasts.
Exactly.
Yes. Yes, that's going back to the game tick. Basically, every time your engine updates, you don't have to do the exact same thing. You know, you could have like every 10th frame, something is done. Every, 12th frame, that kind of thing. You know, you can space it out.
And KB brings up a good point, using the law of diminishing returns. You know, at one point, do you just say, it's not worth me trying to optimize this to get, something like 1 more FPS? Honestly, there's this point in time where you're like, you know what? This is done. We're not going to tweak this anymore.
You know what kind of games have to squeeze out every single bit of optimization that they possibly can? MMOs.
Yeah.
They do. Your turn-based RPG does not. Your side-scrolling Metroidvania does not. Trust me. Okay. Moving on
to myth number 6.
Optimization and assembly. Okay, so let me read this one. This is like a little bit of extra work. For many programmers, optimization and assembly are synonymous. They're not.
No.
But they can't. But they are considered synonymous. Much less true today than it was in the past. Okay.
Yeah.
Right. This is true. Sorry if it angers you programmers out there, but it's true. Okay. When you write the code, I like this right here. When the code you use, not the code you write, is the hotspot or bottleneck, coding with optimized assembly, excluding a shader assembly, will not be your most efficient use of time. For those of you who don't know, assembly is a base language that is the closest thing to machine language or hex that a person can write.
Yeah.
You don't need to do it. Just basically don't worry about assemblies. Use the shaders that are there. Use the renderers that are there. Use the tools.
What is there. The tools are baked into the engine.
And if I'm misunderstanding that, somebody please correct me. But basically, you shouldn't have to go low level at all, ever. Just don't. Basically, trust the tools. If you really want to have a better shader to optimize your game, write the shader yourself. There's no reason, if you know how to program, why you can't. So instead of sitting there trying to optimize and tweak the damn assembly, the damn shader, write a new one. Write one that does exactly what you want. There's a reason why a lot of game companies used to use proprietary engines no matter what.
Yeah.
Because they wanted to have their game engine do exactly what they wanted for their game. Look at the Crystal engine for Final Fantasy 13. That was really well written for Final Fantasy 13.
Yeah, for that time period.
Yeah.
Mm-hmm.
Anyway, yeah, well, any type of compiling anything at runtime Wrath is going to lower frame rate.
Yeah.
Pardon me. Okay, myth number 7. A ratio of 1-to-1 thread to logical core is optimal. I mean, I can understand why a person would feel that way, and I am not a hardware expert, so if you're expecting me to give you some dissertation on how CPU threads work, sorry guys, I'm not that good at that. But basically, it would just seem to make sense that, you know, going one thread to one core does not necessarily mean optimal. Computers nowadays are designed to handle multiple threads and multiple cores. Trust the computer engineers, they know what they're doing.
Yeah, exactly.
You don't have to reinvent the wheel. The wheel does not need to be reinvented. Myth number 8, multi-threading with efficient synchronization will always increase performance. Well, remember, there is no guarantee in anything that you do that it's going to make your game run better. That's why benchmarking is so important. It is the most important thing you can do to test your game. Say it again for the people in the back. If you want your game to be optimized, benchmark it. And if you can afford more than one benchmarking computer, good for you. You've taken one step further than most indie devs have.
Yeah.
Myth number 9, you can determine the performance of a graphics call with the following methodology. I do not know coding that well, but I'm going to go ahead and trust that this guy knows what he's talking about. Sorry, I can't really comment on this one, guys. I'm not an expert when it comes to that. However, I can talk about number 10 because I used to work in DirectX.
Well, let's see if anybody can kind of unpack myth number 9.
Yeah, everybody wants to be able to, that's fine.
Does anybody understand that?
Basically, he's talking, got a little thing here.
You got this code.
This code is understandable, intuitive. Unfortunately, VGO is not.
The missing piece is the work that exists under the hood of the API.
Sorry, guys, I don't know enough about this one.
And the hardware that it drives.
Yeah, but if anyone knows anything about that, please toss it out. I'm going to move on to number 10 because I can actually speak of number 10.
Okay.
Because as I mentioned before, I actually worked in the DirectX 9 library when I first got into game programming.
Yeah.
Working for that studio before they moved me over to Unreal. It was kind of fun, but also harrowing. And the person who was the head of the programming department actually brought up the whole DirectX versus OpenGL.
Really?
Yes, he did.
Okay.
He brought it up because someone who was working alongside me actually brought up, we go faster with OpenGL. And Kevin said, it really doesn't matter which code base you use, it's how you use it. And that has stuck with me. OpenGL is not faster than DirectX. DirectX is not faster than OpenGL. It's the implementation of the code that matters, not the actual code itself. Not for something like this.
Yeah.
You know, anyway.
Okay, I get it.
What does he say?
Yeah, Burke says that myth number 9 is basically it's a render timer.
Okay. I've learned a little bit.
Yeah.
Thank you, Burke. Thank you. All right, so the end of this, before we move on to the next and last little piece, is that a lot of times people think that in order for their game to be optimized, they need to follow a certain hard and fast black and white rules. And that's not the case.
No, technology is advanced and the rules of yesteryear are not valid in today.
Correct. It is true that there are certain axioms, like, for example, real-time dynamic lighting is going to cost more than bloom effect. Anti-aliasing everything or post-processing depth of field is going to hit harder than, you know, crappy LOD, your LODs, whatever. Certain shaders are going to hit harder than other shaders. This is true. That's just the reality of game engines. But there's no hard and fast black and white way that's saying if you do this, no matter what happens, your game will always be more optimized. That is not how it's working.
Yeah.